Hello again. The speakers are here. We can start right now. So I want to start with a quick summarize of the topic of the space and a general landscape of the based rollups. So everything started with Justin Drake's article, influential article about base sequencing, and the time was early 2023, and after that article we have a rough mindset of what is base sequencing and how it works, and we have more standardized stuff. And now, we have only working base rollup is Taiko. The Taiko launched the mainnet after 1 year after the Justin's article, and during that time we have a good base pre-confirmation solutions such as Commit Boost and Prime Luban, and we have other rollups that it wants to be based rollup. And during that time, also we have 18 base sequencing calls run by Justin Drake. At each calls, we had discussed the different approach of base sequencing. So yeah, this is the landscape that we are, and I want to start with the question of to set the tone of the base rollups and of the space. And the first question is for everyone, but I want to ask Justin first to summarize everything. And what were you feeling? What were your initial feelings when you began working on base rollups? And how have those feelings changed over time? And what are you feeling now, Justin?
Oh boy, I need to upload all of the history in my brain. But I think the mindset that I had back then was to try and solve some of the fragmentation and provide a credible solution to decentralized sequencing. One of the things that I guess I was worried about, and I'm still worried about, is the fragmentation of network effects because of silos. Each L2 is a silo, and Ethereum becomes weaker if there's this fragmentation. I guess this has evolved a little bit in terms of the motivation for base sequencing. I think one of them is more of a recent trend where institutions might be interested in base sequencing purely for security, not for composability, right? Like there's some subset of financial applications where they just want maximum security and minimal possibility for failures. And I think projects like Ethereum are evangelizing base sequencing, and we might see some financial institutions move in that direction. The other thing that I didn't completely appreciate is the value of neutrality, even if you're not looking for composability. And I think the prime example here is Namechain for ENS. So here, they're maximally decentralized. There is no governance, and they want to have maximum ossification and credible neutrality. And here, that in some sense, the design space is extremely restricted. There is only one sequencer, which is maximally credibly neutral. One of the things that I guess I underestimated is the difficulty of getting these things to production. And you mentioned this article based sequencing. I guess there was a second article, based pre-confirmations, and my mindset back then was that the major unlock required to get base sequencing is actually the base pre-confirmations, because people don't want to wait a whole slot, a whole 12 seconds. And yeah, it's been over a year now since this base pre-confirmation post, and it has taken longer than I expected. But I think we're going to be making fast progress, especially after the Fusaka fork, because the Fusaka fork delivers an upgrade called the deterministic proposer look ahead, which is in some sense a requirement to do sane base preconfirmations. And this is something that I had missed. I was under the impression that you could do base preconfirmations without any hard forks. But yeah, looking forward to Fusaka and what happens afterwards in terms of unlocking base preconfirmations and therefore base sequencing.
Yeah, thanks for the input. Matthew, do you want to go on?
Sure. Yeah. I mean, I think I get into the Based Rollup like research sphere with the same kind of motivation as Justin, which is that we know that network effects compound with other network effects, right? There's like an exponential kind of curve here. And what we were doing is we had these silos, right? We'd have the superchain, for example, or the Arbitrum ecosystem that were all trying to start from zero. And so their progress was just going to be much slower on that curve. And I think the kind of the original dream is to have all fragments. So Justin called it universal synchronous composability, or the united chains of Ethereum. And I guess the goal was to have all fragments that would call themselves Ethereum members of this this kind of composability zone, and so that we can have all of our network effects start first of all on top of Ethereum and also just progress so much faster along that curve. And I'm still kind of in the same boat as Justin here, where I think the end game is the end game goal is something like that. But I think because of a few things, mostly because proof are taking so long and some other kind of sequencer election issues that we run into at Spire, I've considered that I think it's worth it to use the core idea of base sequencing to just unite a smaller zone. So Spire specifically is working on using a base layer 2 that has already fast block time, so we don't need another form of precomps, and then supporting synchronous composability with any layer 3s that are built on top of that. And doing this all in a way that's like forward compatible. So if the layer 2 becomes based, then all these layer 3s would be compatible and composable with layer 1. So that's our kind of short-term goal at Spire. But I will say, like, as the as more research has been done into precomps and into sequencer election more generally, I think I've noted that there's a lot of there's a lot of proposals out there that include centralized gateways, which I'm personally not a big fan of. I think that there's a significant potential that designs differ from like the original ethos of base precomps, and we end up with a world that may have let's say like big block producers. Like we've had this vision for a long time, but kind of forced onto layer 1 apps, not just layer 2s. And so you can imagine that a gateway that has some pretty different properties from a relay. Like first of all, it has a write lock. It's elected beforehand, and you can only choose one. Things like this that are shared with centralized sequencers, but not with Memphis relays today. I think could end up being like the only way to get transactions onto layer 1 that makes sense. So you can imagine that an application like Stop Aave or something on layer 1 might kind of be co-opted or forced into this this kind of block building design where you have a single large block builder handing out centralized precomp. And while I don't think that that's necessarily the end of the world, and I think it probably will be better than some of the effects of PBS we have today, I think it's quite dangerous to skip there instead of exploring other solutions. So I'm quite bullish on alternate designs for precomps like Tool, not only because I think they have some technologically superior effects, but also because I think they can see adoption from proposers, from validators, a lot faster. And so that's the thing that matters most to me.
Yeah, thanks. And Brecht, what are you feeling?
I'm still like a big believer in based rollups, although like the landscape is like kind of like changing a little bit with I guess like with Vitalik's point as well, like L1 scalability. But I still think that it makes a lot of sense, especially in the next couple of years. But yeah, so for Taiko specifically, kind of like the kind of like roadmap or like thinking of like based rollup and kind of like what problem it solves is kind of like evolved over time. Because initially it was just like, okay, we're trying to make like a rollup that is as decentralized as possible, and it's kind of like, how do you do that? And like, oh yeah, what do based rollups? Well, you get like, I guess, max decentralization with like the max simplicity as well. So it was like a perfect solution at the time. But then, of course, there's like other problems that arise. Like you can't like solve this problem that you want to solve first, and then there's other problems that you have to solve later. Then, of course, the UX problem there, where like block times are like pretty high on L1. Luckily, Justin like find like a solution with like base preconfs. It does take like a long while for it actually to come to in practice, but it is getting here soon, at least like in some form, and hopefully, yeah, with the next hard fork, it will be even better. But then it kind of like evolve from there. It's kind of like, okay, if you have solved these problems, then again, then you get like, the fragmentation problem, kind of like the bootstrapping problem as well, where you do want to have like composability, which base rollups also like, of course, are a good way to kind of like solve this. And yeah, well, I'm now trying to kind of like solve it with Taiko, which will hopefully kind of like combine every good part of based rollups kind of like in one, but that's still coming. But yeah, I'm still like, yeah, very much in favor of based rollups. I think like most, yeah, the practical considerations are getting like more on the forefront, and kind of like, oh yeah, the nice kind of like theoretical properties. But yeah, we gotta have to put in the work, because initially it was like simplicity that kind of like was the main factor, but now it's kind of like, okay, yeah, some of these things are actually pretty hard to actually make work in practice. So yeah, I guess gotta put in the work, but I think it will be worth it in the long term.
Yeah, thanks a lot. So now we have Vitalik here, and actually, Vitalik is the reason of this space, because I decided to talk about based rollups because I saw his latest take on based rollup at the previous podcast. So Vitalik, what are your feelings about based rollup recently, and how it changed?
Yeah, so I think the way that based rollups really came about is in the context of this world where we were expecting the L1 gas limit to not scale, and we were also expecting like L1 to have very sophisticated proposers and to kind of fully embrace that equilibrium and try to get all of the benefits out of it. And like effectively, what based rollups open is they unlock the whole spectrum of basically saying that a rollup is essentially serving the function of just being a shard of Ethereum, like it's a zone that is fully secured by Ethereum, but that has higher scalability and low fees. It's easy to do things within that based rollup, but it requires an asynchronous operation to go between them. But then also enabling like experimenting with like different VM models, different kinds of architectures, and then kind of expanding out into like other things in general. I think for me, the things that changed over the past a year or so are, I mean, so one is that if the L1 is going to scale more, then I think we want to ask like the philosophical question of like in the technological limit, what is the limit to which it's safe to scale the L1, and is it actually different from the limit to which it's safe to scale an ecosystem of shared sequenced based rollups that have this that have the same like level of TPS and the same properties, right? Because ultimately, like if you have, say, an L1 at 10,000 TPS, and you have versus having like 100 based rollups that each have 100 TPS, then in terms, and then they're all in both cases they're being proven with ZK snarks. Then in some sense, like you have the exact same architecture, right? Like especially if you have shared sequencing, right? Because in both cases you basically have one kind of central super builder that's responsible for making an aggregation of 10,000 transactions times whatever the SWOT duration is. Then you have one super prover, and then that gets in, and then those are the transactions that get accepted. And then from that perspective, basically, yeah, there's a good argument, and I think this is kind of the core of academic grads sort of more pro hyperscaling the L1 views, is basically that at that point you might as well just have like native synchronous L1 block space, because that's the UX that the most existing applications are used to and expect. And so if you go in that direction, then the thing that starts to make more sense for L2s is basically do things that L1 will not do, right? And like basically give users benefits that L1 is not going to be able to give them, by taking trade-offs that the L1 is not going to be willing to take, right? Because if you take that approach, then like you're definitely not competing with the L1. You're in actually a different space, right? And like to me, that's actually a big part of the appeal of just saying, well, okay, let's like have a centralized sequencer. Honestly, don't even bother with BFT, because BFT has a lot of complexity. You could have governance to rip out and replace the sequencer if they do anything wrong. So if the sequencer does anything bad, then like users basically suffer for like at most like maybe even 2 or 3 slots if the governance is automated, which I think for something like this you could, right? And like then with a central sequencer, you'd be able to give people average case latencies of like hundreds or tens of milliseconds. You would be able to give people stronger guarantees that they're not subject to any kind of hostile MEV exploitation. So that's kind of like, to me, the central case for like focusing more on separate, like centralized sequencers. I think the other argument for me is also that like I've become less willing than before to kind of go in this all out direction where we say, well, okay, well, layer 1 block builders are going to be centralized. Let's just embrace that. Let's embrace the hyper specialization, because like one example of this, right, is that MEV as a percentage of revenue, then like 2 or 3 years ago, it was like MEV revenue is like roughly matching staking revenue in a lot of cases, right? And today, I think the latest stat is that MEV revenue is about 8.5% of a staker's revenue. And then like basically like the great majority of that is fairly naive arbitrage strategies. And so like there is a sort of possible parallel universe where like we actually say, well, let's like don't like where this whole rush to block builder specialization never really ended up happening, and maybe and like actually it ended up being like kind of long-term fine. And like I think we should at least seriously explore the virtues of going back to that kind of world and like basically getting rid of a big class of centralized intermediaries, because that's better for censorship resistance. And so if we then say, well, okay, we have these central block proposers, and then we're going to overload, like we're going to say they exist, fine, we surrender to that, and we're going to overload them and say, well, let's use them to give people faster block times, then like that ends up entrenching that architecture, and that ends up kind of closing off that door for us, right? And I think if we want to have pre-confirmations, then I think at this point we're favoring, instead of proposers providing pre-confirmations, like somehow the L1 providing pre-confirmations. Like you could very plausibly imagine architectures that have, like say, effectively, like one simple example is if you take the fossil, right? Fossil is already 16 objects that get released per slot. Every fossil object is separate time limit, right? I think this is a bit of an abuse of fossil, because the goal of fossil is to like not become MEV relevant, but this would make it like actually make it very MEV relevant, right? But if you do that, then you've effectively created a structure that then you can sit on that, like you'd be able to plug into and sort of de facto get a 1 second block time. But without actually taking the costs of requiring an L1 to operate with a delta parameter of like less than 1 second, which would be super centralizing. So I think that's the general state of my thoughts today. I mean, I'm definitely like very open to adjusting and readjusting. I think like my main high level opinion is just that like we should be willing to sort of re-explore a lot of these like strive to make sure that the things that we choose are like future compatible with as many of these different approaches as possible. So like we don't needlessly close off any doors for ourselves. So yeah, I think that's basically it from me.
Yeah, I appreciate it. Great input. So, and I want to talk about synchronous composability because Justin said, I mean, for the institutions, security is more makes sense for them. So composability is less attractive. So Brecht, you are working on synchronous composability at Gwyneth. So what's currently missing to achieve, I mean, complete synchronous composability? And do we still need synchronous composability? What do you think?
Well, it seems like if the L1s, like if the eventual goal is for the L1 to scale as much as possible and to have like high throughput, then I think like working on synchronous composability with like different L2s, kind of like emulating what will be possible in the future directly on L1, at least in a lot of cases. So I think this is kind of like a good like stepping stone. No matter what happens on the L1, it's kind of like a nice kind of like way to get there, and kind of like compatible with like also like how Gunit works, where like all the contracts and still and stuff is still like on L1, and like people can freely use the L2 just to, like increase this throughput when necessary, but in the end it doesn't really matter where users are. So like if the L1 scales more, then like gradually more people can actually like gradually move to the L1 again directly. So I think that kind of like makes a lot of sense to me. But what was the other question?
I mean, do we still need it for synchronous composability, or
Yeah,
what your experience at Gwyneth?
Right. So there's like the solutions to be found for like any problem. So you could do like a full synchronous composability between the L1 and L2, but there's like quite a lot of like assumptions that you have to make. So like in the best case, like top of block and kind of like L1 transaction should use some kind of like account abstraction transaction to be able to get them like in the same kind of like super block. But you can like do all these things without any modifications to the L1. So there's like there's solutions for that. There are some like practical difficulties again to kind of like how to get there. So I will be again like proposing kind of like this introspection precompile that makes it easier, so we don't have to be top of block to be able to do all this like fancy synchronous composability. But yeah, in the end, yeah, just making the thing like just like making it stable, making it work. There's actually no kind of like missing pieces to kind of like get there, except of course the ecosystem kind of like has to adopt it, because in the end. What you want for like this kind of like super builder is that there is in the end like one entity kind of like theoretically, or at least for simplicity, that kind of like builds all these blocks together. So in the end, it's kind of like L1 block builders that have to kind of like build these blocks for the L1 and any kind of like synchronous composable L2 at the same time. There are of course like ways you can like find to get around that, but that's kind of like the simplest way forward. But yeah, no real blockers except opt-in and kind of like the ecosystem kind of like adopting these things.
I appreciate it. Justin, do you have any comments of what Vitalik said? Do you want to add something?
Yeah, happy to reflect on some of the things that Vitalik said. Basically, he mentioned that there's this equivalence between one kind of giant L1 versus having multiple synchronously composable L2s. And I guess I want to highlight some of the differences. One difference is that there's a very natural way to shard the RPC endpoints, right? If we have one massive L1, then now if you want to build a block explorer or an application that only uses a small subset of the L1 state, it becomes harder. And there's also this, in some sense, you can think of an L2 as being a way to have access lists for a very small region of state. And it's nice to have this this default shutting point on reasonable access lists. But maybe beyond the technical differences, there's, I think, a big commercial difference, which is around the fact that it seems that the market wants to have branded block space. So if we basically force all of the users of Ethereum to just be basically using and like unbranded L1 block space, it's less of an incentive for people to rebrand the block space. So one of the things that we've seen here, for example, is Robinhood, right? Like, I think a big reason why Robinhood chose Ethereum over a competitor is because they had this opportunity to have more control over the branding. The other thing that I'll say is that this like mega L1, that could theoretically process 10 million transactions per second, is just so far into the future that there is a little bit of path dependence. So the plan, one of the tentative plans that we have for scaling the L1 is to grow 3x per year. And Dankrad wants to do that over 4 years. I want to do that over 6 years so that we get to 10,000 transactions per second. And I think if we wanted to go to 10 million transactions per second, we'd have to wait another 6 years for everything to compound, and 12 years is just too slow. And so I think by going this path of embracing L2s and synchronous composability, we can actually grow much faster than 3x per year. And the way that this would express itself is basically looking at the ratio between L2 activity and L1 activity. The ratio, at genesis of Ethereum 10 years ago was basically it was all of the activity was on the L1, and now today we're at a point where only 10% of activity is on L1. Is 20 transactions per second versus 200 on the L2s, and I think that ratio is just going to keep increasing, to 100x and then 1000x. And the fact that this ratio increases is kind of a lever on top of the L1 growth. And one of the things that I also expect to happen is that there's going to be induced demand, from the growth of L1. So Vitalik said, okay, if the L1 becomes bigger, then there's more space to have the high value applications on it, and therefore there's less of a need for L2s to connect to it. I actually think it's in some sense the complete opposite. So if we have an economically strong L1, there's now more of an incentive for the L2s to come and connect. And because of induced demand, there's overall more activity that Ethereum needs to cater for. And because of the ratio of L2 to L1 activity keeps on growing and growing, there's kind of more and more internal pressure to compose with the L1. And as mteam said, there's these network effects and there's this reflexivity in network effects. And the hard thing about network effects is to bootstrap them. Like, how do you get them kickstarted? And by having an economically strong L1, that is actually potentially a solution to the bootstrapping problem, because we now have this credibly neutral and economically relevant shelling point upon which we can build. And I'm hoping that as soon as we have a template to connect to the L1 economically, a very robust one, then there will be a flood of L2s that will connect to this network.
Yeah, thanks a lot. So Matthew, do you have any feedback, comment on that?
Yeah, I think I I largely agree with Justin on like the differentiation points there. Maybe the biggest one for me is like empirically, we've seen that institutions and some apps want to have their own chain, just full stop. Like I'll point out Uniswap and Unichain here as I think a good example, but we could also look at like Robinhood or Coinbase. I don't think that this is necessarily like a deal breaker, but in terms of like path dependence, it's always going to, I think, look better or to have your own chain, or at least have the option to have your own chain, even if there is a layer one that is super scaled. Now, I want to maybe push back a little bit on the sentiment from Justin and some others on the point that I think we can do a lot of layer one scaling. Like I agree, there's a lot of path dependence, and I think ultimately like a based in native rollup could theoretically get closer to the scale we want faster. But I don't think the layer one is necessarily super constrained here. I think we can, with ZK proofs, especially, and kind of Snarkifying consensus as well as the execution layer, I think we can get pretty far on layer one. But I want to just like especially emphasize that I think the speed at which this development occurs is going to be especially relevant in the current kind of Ethereum ecosystem, because we already have layer twos, and because we already have so much mind share built up around the idea of multiple different layers. We can put a lot of emphasis on scaling layer one, and we can spend a lot of our research cycles doing that on like just scaling. And I think we should do some of that. We should definitely continue to scale layer one as much as possible without disrupting other priorities. But this also means that we're kind of forced to make a trade-off here and neglect some of the existing layer twos that we have. And I'm of the mind that I think Base, especially among others like Arbitrum, has been incredibly helpful to the success of Ethereum from like a consumer perspective. Like I don't think it's been we've had like a large consumer influx into Ethereum since NFTs and DeFi summer, and so kind of remodeling some of that I think has been really important. And I think any kind of scaling plan has to keep in mind that there's a significant risk of kind of neglecting to continue to support those ecosystems that I think are not necessarily like will always exist under the Ethereum umbrella or will always be rollups. And so, yeah, again, I think we have some very valuable assets that are, especially in Base, Arbitrum, and other layer twos that are risks to leave, or could potentially feel neglected by lots of layer one scaling. So that's the one thing that I would point out here. I think again, like we'll be able to go faster with Base and native rollups, which I kind of view as similar to execution shards, except they can be branded and customized to a certain extent. And I think there's a very real risk that scaling the layer one takes much longer. And even when we have done it, there's no route to like returning layer two activity or layer two state contracts, liquidity, whatever, to the layer one. And so that would definitely concern me.
Yeah, thanks. Vitalik, do you have any answers, any feedback, any comments for the previous talks?
Yeah, and I think regarding this concept of like people valuing controlling their own block space, I guess one thing that would be interesting to better understand is like what is the specific thing that they value, right? Because like if you just analyze that kind of economically, right? Like one thing that I would say is that it's valuable to have your own block space so that if some guy randomly starts a $186 million monkey sale, then your user's activity is not suddenly gonna like start costing $4 a transaction and you can't do anything to stop it, right? And like that's the sort of thing that I mean, rollups do partially. They obviously reduce the cost I mean, if you're a sequenced rollup, then of course, like if you have a centralized sequencer, then of course, you always have the kind of fallback option of just like waiting later to submit to L1 instead of everything needing to be in real time. But it's like as a based rollup that like you end up competing with all of the other activity on L1 much more directly. So I I guess I would be curious to like better understand like that piece. I think also just to think about another direction here, right? I wonder, have people here thought about the because I know we talked about like Just and others are interested in the benefits of synchronous composability. The idea that like you could have rollups that have sequencers, but that are also open to based blocks coming in that like that compose across a large number of different rollups at the same time, right? Because like theoretically, that is absolutely something that could be done, right? And like there could be value in L2 that is like has fast block time or whatever in the normal case. But then if someone wants to do a DeFi thing that like flash loans based off of L1 money or just like suddenly does the deposit and withdraw in 5 places, then they're able to do that. So I would also be curious about that too.
Thanks,
I
Justin.
guess
Do
I
we have
can
any
respond to.
answer for that? Yeah, please.
Yeah, I have a few thoughts. So one regarding the fee spikes, if there's one application that becomes popular, I think this was very prevalent in the early days of Ethereum, but it will increasingly become non-prevalent. And the reason is that each individual application will be using a total subset of the block space, which is very, very small. And it might spike from 0.1% of total usage to 1%, but it won't consume close to 100%. And so effectively you have fee smoothing across all of the L2s. In terms of the optionality of being branded, I think part of it is just that we're at the very early days of the blockchain space, and it's very unclear how the application space will evolve. There's like known unknowns and unknown unknowns, and just the fact that you're exposed to the upside of this optionality by having the flexibility is valuable, even if it's not like super concrete. And around the value of synchronous composability, one of the things that has changed a little bit in my mind is that it's not just about the fundamental value of being able to do flash loans and having guarantees on the fees that you pay, and being able to unlock applications that are impossible otherwise. But it's just I think there's also a lot of value in something much more stupid, which is developer experience, right? Like we've built this whole ecosystem around Solidity in the synchronous model. Like we have a lot of tooling there, and one of the things that we've seen empirically is that a lot of ecosystems, actually, I would argue all of the blockchain ecosystems that have attempted to introduce this asynchronous programming model have all failed. And I don't know if it's correlation or causation, but I think there's potentially an opportunity for causation here, where Polkadot, Internet Computer, like Ton, Cosmos, Near, like none of these have really done very well from a DevX perspective in the asynchronous world. But maybe there's a counter argument here that AI is just going to become the new programmer, and they can deal with all of the complications.
Yeah, Justin, I think that one thing you said about synchronous composability really stands out to me. I just want to point out that like all of our existing tutorials and developer infrastructure and developer tooling has been built for synchronous contract calls. Like the call opcode is expected to be synchronous, because they're all designed for working on a single chain, originally Ethereum and now other EVM chains. And I think that people frequently kind of underestimate how difficult it is to not only rewrite all of that documentation, rewrite that tooling, maybe train AIs to think about worlds where where you can do a contract call or a message across chains, but it's not synchronous. And I think that will ultimately lead to, I'd be willing to bet it would lead to security issues and hacks. And also just, I think more practically, in the short term, just more developer complexity. And I certainly don't want to waste time that we don't have to from like building applications. One thing Vitalik said earlier was that a base rollup that's not differentiated block space from layer 1 is kind of naturally competing with layer 1. And I think the way that I personally think about this is that the layer 1's kind of simple service to the world is to provide a network effect that has certain properties. So it's a network that has a network effect, and that network has properties. And I think that a base rollup and a native rollup, etc., has or can have some of those same properties as the layer 1, and thus extend the network effect of Ethereum in the most like pure and natural way possible. And so while maybe competing with a layer 1 for activity or for like transactions, I think it's ultimately net good for like the mission of Ethereum to grow the network effect. And I think that the if we look at it at a more kind of granular level, I think we'd see that the layer 1 kind of gets to offload less valuable transactions. And I think I'd still expect to see some of the most valuable users and transactions occurring on the layer 1 forever. I don't see those leaving at any point. So even if we were to do native rollups and kind of expand the security social contract of a layer 1, or to do base rollups and expand some of the block production pipeline, I think we can still see the network effect of the layer 1 of Ethereum growing, and then the activity of the layer 1 continuing forever without being diluted much. I think I don't know. My natural optimism is to kind of think that a lot of the layer 2 activity will be in addition to layer 1, or be additive and not necessarily competitive, because there's no need to have like competitive state anymore if everything is composable.
Yeah, just I think when I was in my last reply talking about competing, I wasn't thinking for like mindshare or adoption in some long-term sense. I think I was talking more about like short-term. Yeah, I think I also agree with Justin that like that kind of stuff is going to decrease over time. And I mean, I think my kind of somewhat less politically correct answer for why is because like the $186 million monkey people were batshit insane, and I think if you're batshit insane, then over time you go bankrupt. And that's kind of what we've been seeing in this space. But like even still, it's a tail risk that you have to watch out for, right? Like even something like a big hack coming out because of a security issue is something that could easily end up creating that kind of on-chain splat again. Though, I mean, there are also other ways to handle it, like things like the gas futures and so on.
Yeah, thanks. And my curiosity is about, I mean, you said at your previous Telegram message yesterday, I mean, you said if we scale the L1, then the value will decrease, of the value of the L2s as a shards of Ethereum will reduce. So then you said, I mean, the only specific features of rollup will be sequencing. It will be toxic MEV, I mean, fast precons. And do you think sequencing is the only solution that L2s offer, Vitalik?
I think it depends. So like, I think, I mean, obviously scale is one, right? But then I think in the longer term, as like if you're going to offer more scale through L2s than we offer through L1s, then like the question is basically, you know, like what is the actual trade-off that's being made, right? Because like, are we right? Because in the long term, you know, I could imagine, like, especially if we imagine the L1 gas limit basically being like you can have as much gas as you want as long as you're staying within the bounds in terms of data bandwidth, then, you know, is the argument that, well, actually, L1 should restrict more because there's like so much infrastructure watching the L1, and that if you don't need that, then like you go off on an L2 and you're cheaper, which I think is like a plausible argument. But then I also think L2s that don't use like data availability, Ethereum data availability space to the same extent, like are interesting. And like I keep pushing for people to figure out plasma constructions, right? And like you know, these days IntMax exists, and they have this like hybrid model that's really interesting and cool. And I mean, I think theoretically it's possible to make something that's like quite powerful and that protects most of people's funds even for a full EVM. So and then sequencing, like it is extremely valuable to be able to offer extremely fast like latency times and like some of these MEV related guarantees, right? So to me, it's like a combination of those, but I do think it's like still true as a general statement that you know, as L1 scales more, then the value of L2s being particularly around sequencing strategies is something that like relatively increases in importance.
Yeah, makes sense. So Brecht, do you have any feedback or any comments for the previous talks, or can we move to the next question?
No, not really any feedback. I think like just like I guess speed where we can actually add the scalability. I think is currently also the biggest benefit for the L2s. Where, for example, for real-time ZK proving, it's kind of like getting there, but not yet. So it's kind of like some trade-offs that we can make on the L2 to kind of like speed things up to get there faster. Otherwise, nothing interesting to say.
Yeah, thanks a lot. From my end, I mean, the last topic that should be covered is base pre-confirmations. I mean, we mostly covered the nuances, but what do you think in general about the future of base pre-confirmation, or what's the near-term milestone would reignite all of the excitement? Justin?
Yeah, so I'm bullish on base pre-confirmations for several reasons. Like one is that I mentioned there's this Fusaka upgrade that will make them much easier to do. The other one is that we're starting to see pre-confirmations on L2s becoming mainstream. So just a few days ago, I believe that Base turned on 200 millisecond pre-confirmations, and you know, a lot of the concepts and the infrastructure can be reused. So you know, just the integration with the wallets, all of the standardization, even just the cognitive friction of getting used to the concept of a pre-confirmation, all of that, all of the wheels are being greased. And I actually think it's a reasonable strategy to start with what we have and incrementally move towards the end game. I mean, mteam kind of referred to the strategy with what they're doing at Spire, which is you start with an L2 which is not based, you build a whole synchronous ecosystem on top of it, you make sure that it's forward compatible with base sequencing, and then it eventually become base. And I think the same thing can happen for L2s. You start with a centralized sequencer, and then you incrementally turn on the pre-confirmations and the decentralization. So you could imagine, for example, step one being we have centralized pre-confirmations, which is effectively what Base has delivered, and then you can have federated pre-confirmations with some sort of round robin rotation of the leaders, and then you could have a decentralized pre-confirmations, but still not based, and then you could have finally based pre-confirmations as being the end game. Well, there's various ways to play it, and I don't want to leak too much alpha, but I believe that some of the people on this call are working with L2s to basically deploy this exact strategy of incrementally working your way towards the end game.
Yep, thanks a lot. Matthew, do you have any feedback on that?
Yeah, I mean, I think largely the base pre-confirmation, well, I'll give kind of like an overview of where we are right now. I think there's a few attempts at implementation, and I think while some of this work has been heavily based off prior research, I'm not a big fan of any of the existing implementations, but I also think it doesn't really matter. I think the real point of importance for base pre-comps to actually be meaningful in any way is to get validator adoption. And just, anecdotally, we've been doing a ton of kind of validator conversations at Spire, and I know a lot of other people on this call have been. And I think we hear a few kind of repeated reasons why kind of node operators are less willing to kind of opt in their validators for pre-comps. One potential reason is they're just worried about the economics of it. Like is providing something like an execution pre-confirmation, which I think is the most important kind. Is it actually worth it to provide? I think there's plenty of kind of theoretical arguments that can be made kind of on both ends, which is somewhat confusing. I don't know if I have like a fully formed opinion here, but I think that there's some there. I think there's also questions of like complexity, and so if we're using commit boost is like a kind of a sidecar protocol. So yeah, you run commit boost and then you opt into different sidecars, and then those sidecars are part of a broader pre-conf protocol that probably has their own types and also has their own kind of maybe incentives for getting validators to opt in, and then they have their own gateway system. And so you can imagine that there's some complexity that emerges here when we have some competition and no one with a clear lead or with clear adoption yet. And so those are things that I'm worried about. I think there are alternatives. I would, I maintain some fear about the effect that pre-comps might have on Ethereum and like the decentralization of the block production pipeline. I think it's especially important for people to think that pre-comps are not just for based rollups; they are coming for Ethereum. In fact, many of the pre-comp protocols have almost entirely stopped talking about based rollups in their marketing or in their documentation. Have been focusing instead on layer one transactions. And so for anyone building something related to the block production pipeline of the layer one or writing a layer one app that's dependent on that, then I'd be thinking how pre-comps can affect you too, because again, they're not just for layer twos. In fact, many of these projects are working primarily on layer one pre-comps right now. Justin's like progressive approach I've heard it before. I think I'm pretty skeptical that the complexity is worth it. I think for doing centralized pre-comps, that's a good starting point. Just having a centralized sequencer, it's probably a good end game kind of option too for some types of applications and users. And I think that the next step is to, assuming we have some adoption of these protocols, is to move straight towards doing base pre-comps for a based rollup and for the layer one, and then seeing the kind of zone of composability that could emerge there. I think there will be more concerted efforts on doing things like flash blocks or other things like shreds. And I think I'm quite interested in. I know Rise is working on stuff like this. I know this can have some benefits that are. Maybe I'll put it like this: they're somewhat like pre-comps, except they don't have a guarantee associated with them. They're essentially just optimistic, kind of like the guarantees from centralized sequencers today. So maybe they don't have any collateral behind them. They're just kind of a hint at what's going to happen. these type of pre-comps, which I don't know if we can call them pre-comps anymore, but I think this can be quite valuable. I mean, this is essentially what centralized sequencer pre-comps are today, and I think that just that kind of, this will only work on a happy path, but can give you some like 99% chance of it working, can be good enough for many types of applications. Now, like imagine this, like you're doing a approve and swap kind of flow. If you can just get that first approved transaction included, then because it's non-contentious state, then you're going to know what happens with the approval. And so just that little bit of guarantee might be enough to push some like RPCs or apps over the edge in terms of what they can display to users and therefore how fast it can feel. Yeah, I think there's a whole nother conversation around like the MEV effects of pre-comps and maybe also how searchers will use pre-comps. I used to be an MEV searcher, and so I have some pretty strong thoughts on how some of these things can be gamed. But ultimately, I'll say that like there's some incentives we need to figure out, and again, the only way to do that is with validator adoption and then and actually trying stuff on testnet and mainnet.
I appreciate it. So before closing the call, I would like to hear all of your final thoughts by starting with Vitalik. Then we can wrap it up afterwards. Vitalik, do you want to add final thoughts?
No, I feel like I've like said the things that I generally wants to say. I mean, I think I just appreciate all of the hard work that you guys are doing on like really pushing this this whole direction forward, and like seeing how much it's possible to do with based rollups and based sequencing and all of these. So I guess just keep up the good work.
Thanks a lot, Justin.
Yeah, I have a couple of thoughts. The first one is that I'm optimistic about the infrastructure being gradually deployed. One that was mentioned by mteam is that the operators need to actively opt in, at least before we have APS. And Drew has been doing a fantastic job with Commit Boost and Fabric. And I believe if you go on the website now, it will tell you that the dominance of Commit Boost is at 13.5%. But I think the numbers might be outdated, and there might be some big operators who will connect soon. And basically, I'm hopeful that we'll cross the 20% threshold, after which it will be viable to have pre-confirmations. So if you're an operator and you're listening, do consider Commit Boost, because it's fundamentally more flexible than MEV Boost, because it unlocks the possibility for things like pre-confs. The other thing that I mentioned is that I'm very optimistic about the coordinator layer. So I already mentioned Drew, but there's a second person who is going to, I believe, play a significant role, which is Luca Dono from L2Beat. So I think he's going to be spending a lot of his time on native rollups specifically and championing that effort. And the reason why I mention it now is because there's synergies between based rollups and native rollups. And I think maybe one of the biggest synergy is that when you're both native and based, the synchronous composability becomes significantly easier because of the delayed execution. So instead of needing same slot real-time proving, basically real-time proving on the order of the speed of transactions, which might be on the order of hundreds of milliseconds, which is very difficult to do technically, you now have a whole slot, and you can leverage the delayed execution of the L1 and therefore the native rollups. And here we'll start seeing base rollups hopefully truly leverage the network effects of synchronous composability above and beyond the security and the neutrality that they'll provide for one-off chains.
Thanks a lot. Brecht, do you have any input?
Oh no, I guess, but yeah, I guess for Taiko side, I guess we're trying to bring on some of these things in practice mostly. So yeah, I guess the confederation of precoms, whatever Justin called it, yeah, is going very soon to Taiko, and also working, of course, to get towards like the full beast precoms. Yeah, just for like the synchronous composability case and like pre-comps together, I guess, yeah, I guess one thing there is like, yeah, the opt-in rate does have to be like very high for this to actually work out, because yeah, if you want to have like L1 synchronous composability, then you can't do like any tricks with like gaps inside like opt-in validators. So that's why like, yeah, faster block times just in general for L1 also kind of like helps out to kind of like smooth things out when they're not opted in. So yeah, just in general, like I think like hopefully the opt-in rate will be very high, but yeah, it will very likely never be 100%. So kind of like gotta kind of work around that as well. But yeah, otherwise nothing else.
Awesome. Matthew?
Yeah, I think that there's a whole bunch of things happening in the base rollup and pre-comp space, and I think this ties into the broader kind of Ethereum conversation, and really the crux of like how does like where's the place of a layer 2 within the next few years. I think there's a lot of conversation right now around kind of headliner EIPs and kind of what we're going to do for future Ethereum upgrades, and so I think that it's important to be having these conversations, and I just want to give a big thanks to Rise and you guys especially for putting this on, and of course our other speakers for showing up. I will do a bit of a shameless plug here. At Spire, we're working on all sorts of base rollup kind of infrastructure, and one thing that we've been spending a lot of time on in the past few months, and that we're just about to launch in about a week, is this thing called DA Builder, or it's pronounced DA Builder. But the simple idea, and I'm sure other people, I think Justin actually originally talked about this, is that we can have lots of blobs from different base rollups, and it's compatible with other rollups as well, can all use the same kind of batch transaction to submit their blobs to Ethereum. And even more than that, we can do shared aggregation. And so if we have kind of, there's set sizes, and so if we have kind of half of a blob being filled up by one rollup, and then 10 more rollups each take up a hundredth of a blob, we can just package all these together and save a lot of space, which not only kind of saves costs for rollups and the users of those networks, but also it's kind of a scalability secret unlock too, because now we have lots more blob space, and so our capacity kind of increases here as well. And so we're really excited to launch that soon, along with another product that I can't say so much about. And yeah, this is really, I encourage if you're interested in building a base rollup, or if you already have a layer 2 with a centralized sequencer, then come talk to us and we can tell you how you can save lots of money on your batch posting. That's it for me.
Yeah, thanks a lot for joining, speakers. So I become more bullish about base rollups as a base rollup enjoyer even before Justin's article. So thanks for joining. So yeah, we can wrap it up. Cheers.